Good day to you learners out there. You are welcome to the Center for Open Distance and E-Learning of the Federal University of Technology, Minna. I am Joseph Eyitayo Olubusade. I will be taking you on General Physics 2. Today, we shall be looking at the second module of the course, which is hydrostatics. The module is further subdivided into 3 different units. The first unit will be discussing about surface tension. In the second unit of the second module, we will be discussing about buoyancy, under which Archimedes' principle will be vividly explained. And the third unit under this module is pressure. Module 2, Unit 1. Hydrostatic is a compound word comprising of hydro and static. The word hydro mostly refers to water in a liquid form, while the word static describes a stationary body, that means a body at rest, a body that is not moving. Hydrostatic in a simple term refers to the study of liquids at rest, and this describes the equilibrium of liquids and the pressure exerted by the liquid at rest. Now, let us consider forces that are attributed to fluids at rest. Hydrostatic pressure is the pressure exerted by a liquid at a certain depth. As we all know that pressure is force per unit area, we would expect pressure on a surface to behave differently from that in a liquid container. It is good to note that solids have high cohesive properties compared to their adhesive properties. As a result of this, they do not stick to surfaces which they come in contact with. Unlike liquids, some liquids have high adhesive properties compared to their cohesive properties, and so they will stick to materials when they come in contact with them. Cohesion in gas is weakest when considering solids, liquids, and gases. Liquid has both cohesive and adhesive properties. Two forces are associated with liquids at rest. They include surface tension and capillarity. In order to have a better understanding of surface tension and capillarity, let's take a look at adhesive force and cohesion. Adhesion force. Adhesion force is described as a force of attraction between molecules of different kinds. For example, molecules of water and molecules of glass. We can have molecules of mercury and molecules of glass, and so on. Cohesion force. Cohesion force is described as a force of attraction between molecules of the same substance, that means molecules of the same kind. For example, molecules of water are of the same kind, molecules of glass are of the same kind, and the molecules of mercury are of the same kind. To better explain the concept of adhesion and cohesion forces, let us take a look at the action of water on glass and the action of mercury on glass. In the first case, the action of water on glass, we can see vividly that when water is poured on glass, water wets glass, and from this we can see the molecules of water spreading on glass. This happens because water has high adhesion property compared to its cohesion properties. On the other hand, let's look at the action of mercury on glass. We can vividly see here that the molecules of mercury did not stick to glass. They don't wet glass. Rather, the molecules are held together, forming spheres of balls. This is as a result of high cohesion when compared to its adhesion. And so, from this, we see that water wets glass. On the other hand, mercury does not wet glass. Let us consider the molecular behavior of a liquid at rest. In this case, more attention may be given to water because water is the commonest liquid around us. From the figure, 4 molecules of the liquid have been identified. We have molecule 1, molecule 2, molecule 3, and molecule 4. From the figure, molecules 1 and 2 are within the liquid and are said to be in equilibrium because they are attracted by equal number of molecules surrounding them. Let's take a look at molecule 1. Molecule 1 is surrounded by equal amount of forces, and so there's no net force around it. Let's take a look at molecule 2. Molecule 2 also experiences equal amount of forces from the molecules around it. That means the net force around molecule 2 is also 0. However, let's take a look at molecules 3 and 4. Molecules 3 and 4 are close to the surface of the liquid and are not in equilibrium since certain parts of their sphere are bonded in water while the other part is in the air. If we take a look at molecule 3, from this part downward is bonded completely to water, while from the same part upward is bonded to air. And we all know that the forces of attraction between the molecules of water cannot be compared to that of the air. In the same vein, let's look at molecule 4, which is also at the surface of the liquid. From this part downward, the molecule experiences forces from water, and from the same part upward, the molecule is bonded to air. As a result of this, molecules 3 and 4 experience net forces from the water, that means liquid, which causes tension on the surface by straining the surface molecules. This unbalanced force that is experienced by molecules at the surface of a liquid is referred to as surface tension. Surface tension is the force acting along the surface of a liquid, which causes the liquid surface to behave like a stretched elastic skin. It is a force which acts tangentially to the liquid surface per unit length of a line drawn along the surface of the liquid and at right angle to that line. Mathematically, surface tension, which is represented as gamma, is equal to force over length, and the unit is Newton per meter. When defined in terms of energy, surface tension is given as energy per unit area, and the unit is joule per meter squared. Surface tension is justifiable by a small insect walking across a water surface, the spherical shape of dripping drops of water. Soap bubbles have spherical shape. Mosquito larvae holding on to water surface. The floating of a needle or razor blade on water surface. The air of a painting brush spreads out when dipped into the paint or liquid, and pulls together when removed. Excess pressure in bubbles and cupped liquid surfaces. Given that this is a bubble, let us consider the equilibrium of one half of the bubble, which is formed inside liquid. Let the force due to surface tension be F subscript SF, which is equal to 2 pi r gamma. Given that 2 pi r is the circumference of the bubble, gamma is the surface tension of the bubble or on the bubble, and r is the radius of the bubble. Then, force due to pressure P1 is equal to P1 pi r squared. Force due to pressure P2 is equal to P2 pi r squared. And force due to pressure P2 is also given as P2 pi r squared. Now, the total force on the left hand side of the bubble is given as F subscript F plus Fp1. The total force on the right is given as F subscript P2, and at equilibrium, it is expected that force on the right should be the same as the force on the left. Then, excess pressure P is equal to P2 minus P1, which is given as 2 gamma over r. Excess pressure on cupped liquid surface. Cupped liquid surface is otherwise referred to as a meniscus. That is, a meniscus is a cupped surface that is formed when tubes are inserted into liquid. This can be seen in the picture below. As shown in the picture, we can clearly see that there is a cupped part at the surface of this liquid, and this is what we refer to as a meniscus. From the picture, let's go to the right hand side of the picture. P2 is the pressure at the surface of the liquid, while P1 is the pressure within the liquid, and the cupped liquid surface is having an angle theta. Hence, if r is the radius of the meniscus, gamma is the surface tension, and theta is the angle subtended by the meniscus. Hence, the pressure, that is excess pressure on the cupped liquid surface, is given as 2 gamma cos theta over r. At some point, surface tension can be desirable. At other points, it may not be desirable. It can be desirable when we make use of umbrella and canopy. Surface tension prevents water from percolating into these materials. The undesirable part of surface tension is when we need to wash our hand or dirty materials. With surface tension, things become difficult to wash with ordinary water. Then the need arises to reduce surface tension when not desirable. We can reduce surface tension by increasing the temperature of the liquid, and we can reduce surface tension by adding impurities such as soap, detergent, alcohol, oil, and so on. Also, it can be reduced by piercing the surface of the liquid in question. Let us talk briefly about another force that is associated